G'day, year nines. I hope you're having a fantastic start to your last term of year nine maths. My day is working out very much like yours, actually, because I'm on a maths course today, and I will have been spent the whole day sitting in a classroom doing maths. But I wanted to put together this clip for you just to summarize some of the main points for what you're learning today. And I'll do that first up by having a look at what you did last year, because you might have forgotten it by now. So last year, you would have done some work on transformations, and you would have learnt about three types of transformations. You would have learnt about a translation, which is sometimes called a slide. You would have learnt about a rotation, which is sometimes called a turn. And you would have learnt about a reflection, which is sometimes called a flip. Now, the thing that's the same about all of these types of transformations is that they don't change what the shape is that's being rotated or flipped. They're just ways of moving the same shape to somewhere else. And the shape that you have at the end of it is exactly the same shape that you had at the start. And another way of saying that would be to say that the transformations all result in congruent shapes. So congruent shapes are shapes that are exactly the same. So the shape at the end is exactly the same as the shape at the start. It's just somewhere else. You would have also learnt some terminology. So if your original shape was called shape A, then your transform shape, which is sometimes called the image, would be called A with this little dash by it. And the way you say that dash, you'd say this is A prime. So shape A is transformed to be shape A prime. And I've got an example of that for you. So let's say we had this rectangle here, which I've called rectangle A, and we're going to put it through a translation. So we're going to slide it somewhere. And we're going to slide it to the right and down. And so our original is A, and our image here is A prime. And these are congruent shapes because they're exactly the same shape, they're just in different spots. But the transformation you're going to be looking at today, just ignore this text to the right, it's exactly what I just said. The transformation you're going to be looking at today is a dilation, and a dilation does change the shape, and it changes it by making it smaller or larger. So you need to write this down. So your heading would be dilations, and I want you to write down, you can also transform a shape by changing its size. This is called a dilation. A dilation can be either a reduction, which would make the original shape smaller, or an enlargement, which would create an image which is larger than the original shape, of course. So just pause the video while you get that down. Meanwhile, I will move right on. All right, if you got that copied down, I've got an example for you of exactly this. So we've got a triangle here, which I've called triangle B. And we're going to put it through an enlargement dilation. So here we have triangle B prime. You can see that it's got the same proportions as this first triangle. It looks exactly the same. It's just bigger. So instead of being congruent shapes, we would call these similar shapes. So I want you to give some thought to how you would describe this dilation to someone else so that they could do the same thing. So that if you gave them triangle B, they could make triangle B prime. So with our translation before, the instructions would slide it to the right and then slide it down. That was the example we used before for our rectangle. What instructions would you give someone for what to do to triangle B here to turn it into triangle B prime? I want you to pause the video and give that just about a minute's thought and maybe some class discussion. And the conclusion you might have come to is that you might tell them that triangle B is triangle B prime is 3 times larger than triangle B. So this 4 centimeter side has become 12 and this 3 has become 9. And that would be a really good description to give. In other words, and the term you need to become familiar with is scale factor. So the scale factor is 3. The scale factor for this enlargement is 3 because we multiplied each side in triangle B by 3. And you need to copy this formula down into your notes. So the formula for calculating scale factor is the image length divided by the original length. And I put a note below that it has to be for matching sides. So in this case here, if we match our 4 centimeter side with our 12, and our 3 has to match with our 9. So our image in this case would be 12 centimeters long. Our original is 4, so 12 divided by 4 would give us 3, which was the scale factor we came to before. Or if we use this pair of sides, then 9 divided by 3 also gives us 3. So as long as we use matching sides, this formula will give us the scale factor. Now, also I want you to notice that if the scale factor is bigger than 1, what is happening is an enlargement. But it's possible that the scale factor could be smaller than 1. It might be a quarter or a half. And then you would have a reduction. So pause the video and copy this formula and the notes down. And now I want you to use that formula and these skills to try and solve this problem. So we've got 2 trapeziums, and I want you to work out what is the scale factor for this transformation. So pause the video and do that now. And now we have the solution to that. So the first thing we need to do is make sure we've got matching sides. Our trapeziums are arranged in the same way around both times, so that's fairly easy. Now, I don't like working with decimals if I don't have to, so the sides I'm going to choose here is this 6 centimeter side here and this 4 centimeter side here. So our scale factor, image length divided by original, we've got 6 divided by 4, which could be simplified to 1.5, or if you divided 6 by 4 on your calculator, you get 1.5 as a decimal. Now have a look at this one. It's a little bit trickier. Again, pause the video and see if you can work out what is the scale factor for this transformation. Now you'll need to know which shape is the original and which is the image, and you'll need to pick a pair of sides. All right, so the pair of sides that I picked is this 8 centimeter side and this 12 centimeter side. So the 8 is the image, the 12 is the original. So it's the sort of long side on the back of the L on both of them. So we get 8 divided by 12, which we could simplify as 2 divided by 3, which comes out as 0.667. All right, now practice from the textbook as it says on the screen.